Good day, everyone. Today I'm gonna talk all about wood as an engineering material. So first, what is wood? Wood is a natural organic material that has been used for many centuries for the construction of buildings, bridges, and a variety of other structures. So it has been used for thousands of years, and via technological advances, it made it even more valuable than the previous years by its usage. So next is the types of wood. So there are the types of wood is categorized into two: the softwoods and the hardwoods. Softwoods are coniferous and include spruces, pines, and firs. So these trees generally retain their needle-like leaves throughout the year. So for example, the cedar and the pine woods. So these are the example of the softwoods. So the next is the hardwoods. Hardwoods, however, are deciduous and include oaks, birches, and maples. They have broad leaves which they lose in winter. So for example, we have mahogany and walnut wood. So next is the structure of wood. So the structure of wood is in coniferous softwood species. The wood soils are mostly of one kind. As a result, the material is much more uniform in structure than that of most hardwood. So so there are different parts of the structure of wood, but we are focusing only the hardwood and the softwood, which encompasses the two materials properties, which are the compression and the tension. So the compression part encompasses with the hardwood, which this only retains because because the hardwood is composed of less moisture. That's why it has more resistant in compressive forces, while the softwood is more moisture. So thus it has less resistance to compression, but it is more resistant to tension. So, since just like what I said earlier, since that source tree has been exposed to many factors in nature, especially wind, making it necessary for the trunk to have two materials properties. So next is let's proceed to the properties of wood. So these properties of wood encompasses of two: the physical and the mechanical. The physical properties of wood include the density, shrinking, and swelling, thermal properties, and durability of the wood. So density indicates the stronger wood, meaning the higher the density, the stronger the wood is. Shrinkage is a reduction of linear measurements. The thermal properties is indicates the thermal conductivities and the coefficients of thermal expansion, which has a low. And its durability is the ability of wood to resist degradation under uh, under the under the action of external forces. So mechanical properties of wood include stiffness and elasticity, tensile strength, compressive strength, shear strength, toughness, hardness, cleavability, and resilience. So these mechanical properties symbolizes all the strengths of the wood. So basically, that is somehow represents the strengths and the deformation or the ability of the or the pliability of the wood. Next is let's proceed to the common engineering products. Common engineering products composes of only four. Basically, there are more, but I include only five common products, which is the lumber that is harvested trees that has been turned into planks or boards. Engineering wood products are a combination of wood or wood byproducts and various adhesives to make different products. Structural composite lumbers, so through layering wood, veneer strands of flakes and adhesives, which are then cut into specific sizes, and then panels. Those are the both structural and non-structural panels. And the mass thin member is a new and innovative style wood construction where large wood beams and thick panels are used for walls and roofs and etc. So, uh, by for to conclude, wood is a important and essential engineering material that is useful for developing essential or efficient structures and buildings. That's all. Thank you. So good morning, everyone. So today I'm gonna talk about asphalt. So, what is asphalt? Asphalt is a mixture of a aggregate, spinner, and filler used for constructing and maintaining all kinds of roads, parking areas, and also for play and sport areas. So, asphalt is a bitumen class hydrocarbon mixture, typically having a dark brown to black color. So, this is an example of a roadway having a um, asphalt on top of it. Okay, so next is the process on making the type one type of an asphalt, which is the hot mix asphalt or the top that top surface asphalt. Okay, so first is the aggregates is being stored in stockpiles and then put into cold feed bins and then being dried and heats aggregate before mixing it with the asphalt cement, and then the emission control system will filter all the fine sand and dust particles from the exhaust air, and then it will go to the storage silo where it holds hot mix asphalt until it's time to load onto trucks for paving jobs. So that is an overview of an asphalt. So next is what are the different types of asphalt or kinds of asphalt. So first, there are three main types of asphalt. So the top layer asphalt, also known as the surface mix or the hot mix asphalt, which is by the far most commonly used asphalt mix. So these mixtures are placed after being heated to between 300 to 350 degrees Fahrenheit, that is somehow 100, 150 to 170 degrees Celsius. So next is talks about the warm mix asphalts. Warm mix asphalt is a more fuel efficient option than hot surface mix and only being heated to 200 to 250 degrees Fahrenheit. So this kind of asphalt is an eco-friendly asphalt which emits less carbon dioxide, and it is a valuable solution for the clients seeking for a green solution. So next is for the cold mix asphalt. So cold mix asphalt is mainly used for soil repairs, and it tends to have a short lifespan and should only be used as a temporary or the last resort for a repair. So those are the different types of or kinds of asphalt. So let's proceed to the asphalt layers. So asphalt layers consist of four. So let's start from the top. So asphalt surface is the approximately 4 centimeter in its thickness and must be replaced after 12 to 15 years. So it helps to having a handy and wear resistant aggregates help to optimize its durability. So next is the asphalt binder layer, which is approximately in 8 centimeters, and the core function is of binder is to quickly and effectively derive shear forces and vibrations from the road surface in the lower layers. So next to the asphalt binder layer is the asphalt base layer, which is approximately 22 centimeters, and the asphalt base layer serves to accommodate the high loads and to distribute them to the underlay. So next is the asphalt frost protection layer, which is approximately 34 centimeters in its thickness. So to prevent damage caused by frost, a frost protection layer is often used below the asphalt layers. So those are the different asphalt layers. So next we have the pros and cons. So the pros and cons is so the pros in using asphalt is economically advantaged, durability, safety, recycling, and maintenance, while cons are care and sealing, cracks, environmental issues, construction, and equipment. For the next is the asphalt application. So asphalt application trans there are derives from transportation, which means roads, bridge decks, railway beds, or airport runways, and then recreation. For basically, it is used for flooring or making roads. So those are the physical asphalt application. And then the asphalt versus concrete, considering the ease of installation, asphalt is more advantage. Considering the climate, um, asphalt is good for cold temperature while concrete is applicable for warm temperature. And considering the environmental impact of paving materials, asphalt is more environmental friendly because it can be recycled. While considering a longevity, concrete has a great advantage in this portion. So those 6 topics only um, Those six topics produces the overview of the asphalt, and that's where end my report. Thank you and good day.